Hi guys, I'm Darren, and in this video we'll be checking out how to set up the Archer SR receivers. So I already have a video on setting up the original stabilised receivers that FrSky produced, that being the S6R and the S8R. So I'll put a link up in the corner for those. And like with that video, I'm going to be setting this up on ETHOS, but the similarities between ETHOS and OpenTX are very similar. There's a slight couple of differences when you're setting up the mixes. The reason I'm making this video is because there are a few subtle differences between the SR series and the SXR series, other than obviously one is Access, the other is ACCST. So what I will do is go through those as well. And also particularly with this SR10 Pro receiver, there are 10 outputs here, but 2 of these outputs are used by the gain and the modes by default. So I'll also show you how you can set this up so you can keep all 10 channels here. So let's check this out. Right, so let's go over the setup of what I'm going to be using in this demo. So I'll be using the X20S, I'll be using my little plane, I'll be using this SR10 Pro, and I've just got a BEC and a battery to power everything. I know that this you can directly plug power into, but it outputs that power directly to the servos, and I don't think these can handle a 2S pack. Anyway, let's get started. So I'm just going to start the radio, and I'm going to create a model from scratch. I'll probably speed this bit up because it's going to be something that you probably know how to do already. We're just going to go into the model wizard, and we're going to set up a standard plane. I'm just going to use all the defaults. Right, so we've got our model. I've called it SR demo for the receiver. So if we go in the mixer, what we can see is we've just got a standard mix. I have 2 aileron channels, 1 and 5. I've got the elevators on channel 2, throttle on channel 3, rudder on channel 4. So this is a standard aeroplane setup at the moment. So the first thing, of course, what we need to do is register and bind the receiver. Again, I'm not going to go through this in massive detail because I've covered this in other videos. But we're going to, I don't know why I can't default that. But anyway, we're going to turn on our internal module. We want it on access because this is an access receiver. You don't need to worry about the 900 size unless you're going to use a 900 redundancy receiver. But for this situation, I'm not. I'm just going to use the 2.4 gigahertz turned on and use the internal antennas. Right. The first thing that we need to check is this model range here. You need to make sure that this is on 1 to channel 16 at the least. So if it's on 1 to channel 8, it will actually not work. You won't get the stabilisation features on there, or you might get them, but you won't be able to change them. So just make sure that that's on channel 16, which should be the default these days. So let's register. So we'll just click on register. I can just plug the battery in for this, hold down the failsafe button and plug in, and see our SR10 has popped up. Just click register, registration OK. So we'll power that back down, and what we'll do is we'll bind it. So click bind and then just power in. Now you notice at the moment I've not connected any servos, and there's a reason for that, because we need to calibrate this and it's much easier with nothing connected at all. I'm going to choose the SR10 to complete the bind, and that's it. We're all good to go. If I had the model plugged in, I could control it. So that's all we need to do in this section for the minute. What we're going to do is go across and we're going to go to our device configuration. Now, what we need to do before we do anything else with this receiver is calibrate it. And obviously this is much easier to do now when it's on the desk and not in a model. So it's just a simple case of following the pictures. So that is matching that. We just need to go down and click. So the lights are flashing. When it's done, it tells us what the next step is. So we're literally just flipping it over. Done. All right, these steps here are quite straightforward, but what I like to do with these on the side ones is actually have something that I can just put it up against. It makes it easier. So this one we want the pins up. So I'm just going to put it against my soldering station here. Just make sure that it's vertical. It's quite handy having the lines on it. So you can see that in the camera actually, it's pretty good. And we'll click done. The reason I do this is because obviously you've got the antennas out the bottom, you've got the power out the top. Just sort of sticking it on your desk is not the easiest thing. So we'll just flip it up the other way. Done. Okay, so we can get rid of that. Now this last step can actually confuse people. It's confused me before, and I've just actually spotted why. The wizard is actually wrong. So I will be raising a change request for that on the ETHOS GitHub. But basically you want the label facing you so that you can read it, which will put the pins on the right. So stand it on its side, label facing you, pins on the right, and click done. Once that's completed, what we need to do is just flip it over 180 degrees. So the label is still facing me, but it's upside down so I can't read it. The thing is, it still says here pins right when it should say pins left. So don't worry about that. Just have the label upside down and facing you and click done. Once that's completed, you can click again and the calibration is all complete. So basically we're done with this now. We can unplug it. It will remember that calibration. We don't need to do that again. It's probably worth doing after a flash, but it's saved for settings. So what I'm going to do now is just get this all plugged in and I'll come back shortly. Okay, so this is all connected now. Just to go a brief run through, I'm using AETR, so I have left aileron, elevator, throttle, which is just connected to the UBEC, rudder, and then I have right aileron. So that was the 5-channel AETR that we have in the mixer. And what I've also done is I've taken the liberty of plugging my flaps in to channels 9 and 10. Now, if you've used one of these before, you know that channel 9 is the gain and channel 10 is the modes. But I will show you a trick later on so you can get those back as functional channels. So what we need to do first of all is set up some mixers so that we can communicate with the receiver here. So we'll come back out of here, we'll go into mixer and we're just going to add a couple. So these are all going to be free mixes and they're all just going to go at the end. And the first one that we're going to add is for our gain, which I'm going to put on this pot right here. We want this always on. For the source, I'm going to just use this pot. Now with the gain, the way that it works is it actually only needs half of the signal. So it works from 0 to 100. And at the moment, if you see, our pot goes to -100 to 100. So what we need to do is add a curve. Now this is the way you set this up in ETHOS. We just go add curve. In OpenTX you need to set this up on the curve screen, so that's slightly different. I'm just going to call this gain so we know what it's for. And the type of curve is a custom curve. We just need 2 points and all we need to do is change 0.2 to +100. So now you can see the whole width of this curve. We're starting at 0, we're going up to 100. So our gain pot will get the whole movement. So we have all that resolution. In the middle is 50% gain, obviously based on the range that we select in the firmware, and 100% and 0%. What we need to do, of course, before exiting is assign it to a channel. So we're going to put this on channel 9. And we can use the same name. Right, next up, we're adding the modes. Now in this setup, I'm going to be just going through the easy setup option. I'm not going through the advanced version, which has knife edge and hover. If you want to try those, you do need to set it up slightly differently. Let's add on mode. Again, this is going to be a free mix, again, right at the very end. We'll call it modes. And I'm going to put this on switch SA. Of course, you can choose whichever switch you want. And what we need to do is just assign it to channel 10. Okay, and it's going to ask if we want to give it the name modes, and we do. So that's our mode switch set up. So we only have one other switch to set up, and that is the self-test and oh crap switch. So again, we'll stick it at the end. I will call it oh crap. And if you want to blame anyone for that, it's flight test. And we need to assign this to a free position switch. It would be, I think, better to have it on a momentary switch, so that if you do get into trouble, you can hold the momentary switch until you recover, then let go. I think that would work much better. Maybe I'll show you how we can set up both switches on the same channel. But for now, I'm just going to put it onto SD because we do need that middle position for the self-test. And this one goes on to channel 12. Right, so that's everything set up as far as we need to at the moment. What we need to do now is just check that the stabilization is correct. So you set this receiver up in your model with the pins towards the back. And I've just plugged in the battery. So you can see we have aileron, elevator, rudder, and you can see some of it's going backwards, some of it isn't. But what we're going to do is get our stabilization working first. So we'll go into device configuration and you go to SXR. Right, so this is where you will need to change your setup. At the moment, by default, it's set up for a standard fixed wing. So rudder, elevator, aileron. If you're using a delta or something with elevons, so you would choose the flying wing setting. Or if you're using a VTOL, you would choose the VTOL setting. So I'm just going to stick with the standard. Next up, we have the mounting options. So the options we have are level, which is like this. We have level reversed, which is upside down. We have upright, which is on its side. And we have upright reversed, which is on its other side. So you notice there's nothing for having the pins forward. They should always be set up with the pins back. But I'm just going to leave this on level because it's level on my desk. The next option we have is SXR enable. So if you set this to off, this will do nothing. It will just be a standard receiver. It'll be effectively an R10 Pro. And then what we have is the ailerons inverted, which is what we're going to check now. So you might have noticed it's moving about because I'm in the self-leveling mode. So in the middle, it'll be the stabilized mode, and at the end, it is the manual mode, so there's no stabilization at all. So what we want to do is put it into the self-leveling mode and crank the gain right up. Now, what we need to do is make sure that the plane is reacting correctly. So if we roll the receiver over to the left, we need the plane's control surfaces to react as if it wants to roll to the right. So you can see here that my right aileron's gone up, the left has gone down, so it's reacting correctly. If it wasn't, you would just change these inverted things here until it was. The same goes for the pitch. If we raise the nose, we want the elevator to go down to push the nose down. And then the same with the rudder. Now, the rudder should follow the rotation of the nose. So if we turn the receiver to the right, the rudder should also go to the right, which this is why we turn the gain right up, because it's easier to see it. So you see when it's turning right, the rudder is going right. So all the stabilization is correct on here. And the reason for that is because I've set it up already. But all you'd need to do is invert these. At the moment, I'm using 2 channels for the ailerons. If you didn't want to and wanted them as auxiliary channels, you can turn them off here, or turn on the auxiliary side here. So if I choose that, it means that channel 6 is not elevator, it's just a normal channel. Quick mode is what I was referring to earlier. This is setting up using quick mode. The switch positions are completely different for having quick mode off. So you need to use 2 switches, one to channel 10, one to channel 11, and the positions are completely different. So it's much easier just to turn quick mode on and set it up like this. Next up, we have the stabilisation gains, which you can change whatever you want. I don't really touch those. I can get this where I want it at about sort of 30%, seems about right. But there are a couple of settings in here that it's worth just checking out. So we have auto level angle of aileron and auto level angle of elevator. And these two you can adjust to get it flying level. Sometimes you may find that when you're flying along and you put it on auto level, it will want to nose up or down. Ideally, it should want to nose up, because when you do the self-test, you're supposed to raise the front of a plane a little bit so that it doesn't nose down. But if you find that it's nosing up, you can adjust the percentage just to get it nose down. Likewise, if it's trying to bank over, you can adjust the percentage to get it to stay dead level. So that's where you want to adjust those two. So now that our stabilisation is all set up, what we need to do is correct the fact that the radio is not working right. So what we're going to do is go into outputs. Now, if I try the ailerons first, you can see if I bank over to the right aileron's fine, but the left isn't. So I need to reverse this channel here, and now it's correct. If I pull back on the stick, the elevator is nosing down, so we want to reverse this, which is now correct. And finally, the rudder again is inverted. So there we go. So now all our controls are going the correct direction, and our stabilisation is going the correct direction also. So we can check again. If the plane rolls to the left, it's trying to roll right. If we roll to the right, you can see it's trying to do it more. So our stabilisation is correct, and also our transmitter's correct. So next up, what we need to do is do a self-check. And what this will do is check the range of everything on the setup. Now, to do this, if you're using rates, you need to put your radio in high rates. And what we're going to do is just flick this switch 3 times. Now, you can see the blue light came on, and in a minute it will start blinking. And then after a few seconds, I think it's about 8 seconds, it will go through the self-check procedure. But this is slightly different to how the SXR worked. So I'm doing this on purpose to show you in a sec. Of course, you should be nose up slightly. But now if I move my sticks, nothing happens. Nothing happens at all. That's because the procedure is slightly different. So what I'm going to do is flick the switch again. So when it starts blinking, I'm going to move my sticks to the full extent. This is why we do it in full rates. And then again, after the 8 seconds, it will do the self-check. So now everything is set. We have our full range of movements, and everything is gravy. Now, there are a few things that could cause you problems getting into self-check. One of them I've seen is if the throttle's too high. So this will mainly affect people who are flying sort of nitros or anything with an internal combustion engine, and you need, your throttle linkage requires quite a high setting. I believe it needs to be that the throttle output is below 74%. So if I try that now, it's not going to work because the throttle's too high. But if I go just under 74, it should work. So that's 74 there. Didn't work. That's 76. Didn't work. But anyway, if you get your throttle down, it will work. You can see it's come on there, so I'm going to have to move my sticks again. So that's one thing that can cause this not to work. There is one other thing that can stop that self-check happening, and that is actually something in ETHOS itself. So if you set this up and find that the self-check doesn't work, if you go into hardware in the system menu, open up switches settings, and this top option here, the switch middle delay detect, or detect delay, by default on some versions of ETHOS that was set up to 100 milliseconds. If you turn this down to 0 milliseconds, it will work. So there are the two things that can catch people out in getting into that self-check mode. Right, so that's basically everything set up. So what I'll do is I'll just show you these modes. Obviously, I've shown you the self-level before. In the middle is stabilisation. So you notice if I bank it right over, it's not trying to correct the plane. It's just taking out little movements, from wind. And then also we have the full manual control with no stabilisation whatsoever. If you want to reverse this switch position, so for example, manual is at the top, all you need to do is go into your mixer setting, go into modes, and down the bottom you can reverse it here. So now at the top is manual, and at the bottom is the full stabilised. So I'm going to put it in manual on purpose because I mentioned the oh crap switch, which is currently set to here. What I'll do, I'll show you it working, and then we'll also add a second switch to do the momentary. What we're going to do is I'm going to bank the plane over, but yeah, we're flying, we're inexperienced, we're in trouble. If we flick this switch, it activates the self-leveling mode and will self-level the plane. As soon as we are confident we can take control back, we can put it back to normal and fly in manual. So that works pretty well. But as I said earlier, that would work much, much better if it was on a momentary switch, because then you just need to hold it in. So what we're going to do is we'll create another oh crap. Sorry, that's probably going to be quite funny to our American friends. Oh crap, mom, for momentary. So I'm going to set the source to the momentary switch on the back. We could use this one or whatever, but I'm just going to use the back. So I'm going to return that. And what I'm going to do is set the active condition. I'm going to hold the switch in and then return out. So this is only active when I'm pressing the switch. We're going to go to replace, and we're going to stick this on channel 12. So now what we have is we're in manual. If I hold the momentary switch, we're in self-leveling. As soon as I let go, it's back to normal, but this switch here will operate exactly the same. So that's how you can set it up on two switches. Right, so that's everything set up. But as I mentioned at the beginning, we have these two flaps in our gain and our modes. Now, I did actually have them switched off. I was sneaky, so it didn't really interrupt us during the demo. But now if I move the gain pot, you can see this flap here working. And if I flick the modes, you can see that flap there working, which of course is not what we want. We want these as flaps. So the way we change this is we go into our RF settings, and right next to the bind, there is a set box. And in there, we go to options. And if we go down the bottom, you can see we have pin out 9 and 10, our channels 9 and 10. Now, this is the default options, but there's nothing stopping us changing these to be channels 13 and channels 14 and putting our flap switches on channels 13 and 14. That means that we're effectively just bumping on by 4 channels. We have all 10 channels here available to us, plus we have 4 channels being used for the stabilisation side. So let's go and set our flaps up on a different switch. So what I'm going to do is just leave this as is for the minute, and I'm going to go back into the mixer and I'll add another mix. And there is already a flaps mix in ETHOS, so I'm just going to use that. I'm going to stick it after the rudders just to be different. Input, I'm going to use this switch here, and I'm going to output flap 1 on channel 13. And flap 2 on channel 14. So now we have our flaps. Of course, this is not set up correctly. It's going to have an off-center point, but I'm not going to bother sorting all that out. I'll let you guys sort that out. This is just to show how this works. So flaps are on channels 13 and 14. We'll go back into our RF. We'll go to set, options, and we will go down to our pin 9, and we're going to change that to channel 13, pin 10, channel 14. So our flaps are now operating off of our switch. Our gain pot no longer has any output. Our modes no longer has any output, other than actually, of course, changing the modes. But we have all access to every single pin. It is a shame that we can't just move where the stabilization channels are, because, you know, potentially we could just go into our device config, SXR, and then say, you know, gain pot channel 22, mode channel 23, and oh crap channel 24, and then we have lots and lots of options available. But unfortunately, that is one limitation of these receivers. Those channels are fixed, but we can still use all these pins out here, which, yeah, it should be fine for most people. So just to summarize this video, we've set up a basic model, we've registered and bound our receiver, we've set up our modes, gain and self-test switches, we've checked our stabilization is correct. We then went on to correct our gimbals to the control surfaces, and we've also shifted along our channels so that we can get access to all the pins on that receiver. So I hope you guys found this video useful. If you did, give it a thumbs up and subscribe and click the bell icon, and that will help get this video out to more people. And yeah, get out there, fly your models like you stole them. Have fun, guys.